Yeah. You want to give the reminder?
Just a reminder, folks, if you'd be so kind to make sure that your cell phones are turned off. If you need to leave the room and use the restroom or whatever, feel free to do so. Everybody's welcome. Come in and go as you would. That's fine.
Thank you.
Yes, sir.
Good morning. My name is Gaylord Olson. I work for the Jackson County Land Conservation Department. I'm the County Conservationist. The meeting this morning is a public informational hearing regarding Wisconsin Propane LLC non-metallic mining reclamation plan. The public informational hearing is divided into two parts. The company will discuss the reclamation plan proposal for the site. Once they have completed, there will be time for a few questions regarding the reclamation plan. This is not a debate or a forum to discuss the frac sand industry or the rules governing mining. Please limit your questions to the specific reclamation plan proposal here today. The presentation by the company is for your information to help understand the reclamation plan. Items such as road traffic patterns, blasting, and hours of operation are outside the scope of this meeting and the county non-metallic mining reclamation ordinance. To ask questions during this meeting, raise your hand and wait to be acknowledged by me, and I will acknowledge you, and then you can speak or ask the question. The second part of the meeting is for those individuals that want to provide testimony and are part of the proposed site ownership, those people that have property or live within 300 feet of the proposed site or are affected persons. If your testimony is not related to NR 135 and Chapter 24, the County Non-Metallic Mining Reclamation Ordinance, you'll be asked to stop and refocus your testimony. The Land Conservation Department will review the testimony prior to making its final decision regarding the reclamation plan. You will need to come forward to speak into the microphone. I will ask you to state your name, address, and property ownership proximity to the mine site before you proceed with your comments. So at this point, I'm going to turn it over to Mr. Mitchell or Phil Newman from SCH. They can give their comments. Like I said, when they're done with their presentation, then we'll take questions or comments from anybody that's here.
Hi, my name is Jack Mitchell, and I'm the managing member of Wisconsin Propane LLC. And here today with me, I have SEH, who's an environmental firm that's been doing all the designs for the mine site, and also have TBS, who's been contracted to be the organization for the design and build and operation of the mine site. And with that, I'd like to introduce Phil Newman, and Phil's going to take us through a presentation.
Thanks, Jack.
As Jack mentioned, Wisconsin Propane proposed a mine in the town. Thank you. Town of Curran. It's north 99 is down in this area. We have County Trunk G running along the west and north. And we have Adams Road along the east side here. The mine boundary is outlined here in yellow. The total site is about 670 acres. We're proposing to mine approximately 370, and then a plant site of about 80 acres. This exhibit, we have been out on site, delineated wetlands. That's these areas shown in blue here. And then the yellow arrows show the existing drainage patterns. The proposed plant in this area, we're going to stay out of the wetlands. We're not impacting them. We're mining. There's a chance that in the future, the mine footprint just touches this one. That's many years out. We will be coordinating with the DNR and Corps if we're going to still mine in that area. Otherwise, we'll totally avoid that wetland also. Here's the operation site plan again. Yellow boundary of the mine site. Outlined in green is the actual mining limits. The mine limits have been set by a minimum of a 50-foot offset from adjacent property outside the mine, where it borders, and then the curvilinear line here is basically it's the edge of the resource. Preliminary, about 19 preliminary soil borings were done to investigate the resource. And at that elevation, this elevation is approximately 2 feet above the proposed mine floor. And this area is the processing facility, again, about 80 acres. In a few minutes, I'm going to go through the general proposed processing there. The plant does include a washing operation, the processing site. We're going to have washing operation and a dryer and room for stockpiles for both the raw sand, processed sand, and the reject sand. As far as the mining operation, we've broken this down into phases from about half year to a year and a half in length. We're going to start near the processing site, working in phase 1, 2, 3, 4 consecutively. General movement is come immediately west of the site, and then flip-flop back and forth to these areas, and then move along to the north and then to the west in those areas. So that's just kind of the general process. As far as the mining operation, just in general terms, first operation is going to be construction of the processing site. As we get into mining, topsoil will be removed and stockpiled. The B horizon soil right below that topsoil, which is about an average of 30 inches. Topsoil, there's about an average of 7 inches. That will be stripped, stockpiled for future reclamation. Then the overburden above the sand resource will be removed and stockpiled. Then sand will be extracted and taken to the plant for processing. In general, the processing will include crushing, and then it's going to go through a washing system, screening, sizing. Will then be conveyed to the dryer, where it will be dried and again sized into different products, and then stored in silos for loading onto trucks to remove to an off-site rail loading facility. As part of the processing plant, we have proposed a high-capacity well. Application has been submitted to the Wisconsin DNR. That well is proposed to be about 300 feet deep. There are also going to be 2 low-capacity wells for the office and a maintenance building. Those are going to be supposed to be about 80 to 100 feet. Applications have been submitted to the DNR, and they are reviewing those. High cap well is going to be used for makeup water. The washing process is a closed system. We're going to have a couple process ponds that all the wash plant area, washed stockpiles, they will drain to the process pond for reuse in the system. The high cap well, it's estimated about 250 gallons per minute will be the makeup water for water loss during the process through evaporation. Just this week, we have completed the installation of 6 monitoring wells. Those are basically surrounding the site. They'll be on the project site, but they'll allow keep track of both water level as well as water quality. We can take sample from those processing ponds, which will remain in this area throughout the life of the mine, so we can monitor groundwater. It's anticipated that the mine floor is always going to be a minimum of about 10 feet above the groundwater elevation. And again, with groundwater monitoring wells, we'll be monitoring that throughout the process, the life of the mine. As far as the reclamation, it is proposed that this is going to be returned to agricultural land. Again, on this exhibit, a couple things I didn't point out, will be some screening berms along the edge. That will be topsoil and B horizon that will, again, upon completion, will be used to reclaim the site. As we get into the mine area, the first phase after the site grading, we will be working generally in a westerly direction and then north and south to the next mine boundaries. Again, first operation, stockpile, strip and remove the topsoil, stockpile that. Then the subsoil, the B horizon soil, remove that, keep that in a separate stockpile, remove overburden, and then get into the mining. After the topsoil and B horizon soils are removed, we'll construct some storm ponds within the mine phase. We're going to keep all the mining internally drained. We'll do that by, again, here is basically the edge of the resource from the soil boring. We're setting that elevation about an elevation 2 feet above the mine floor. Remove that topsoil, remove the B horizon. The mine floor will always be a minimum of 2 feet below the adjacent land. And then we'll also have a stormwater so that all the open areas are contributory to the storm pond. As that sand is hauled to the processing site, processed, and we'll go through, finish up this phase here, move to the next phase, and as they start, they'll make graded such that, again, any runoff on exposed areas is contributory to the storm pond. As we get into phase 3, we'll strip the topsoil. We're going to temporarily stockpile that. Strip the B horizon, temporarily stockpile that. Remove overburden, and that next phase, then we'll start our reclamation. That overburden will be moved to the previously mined phase, and along with reject material from the processing plant will be used to begin the reclamation of the prior phase. Then we'll be putting the reject sand and overburden down. On top of that, the B horizon soils, and then topsoil on top of that, and then getting that seeded. So that's the plan for the operation. And again, as we move along, the currently mine phase will be used for reclamation of the previous phase. So it's going to sequentially, we'll step through it and reclaim the prior year's phase right behind us. As far as, we'll talk a little bit about the stormwater processing area. I'll start with first. We're going to have both process ponds as well as stormwater ponds. It's going to be designed such that the wash plant area and the wet sand, the wash sand stockpiles, those are going to be, the site is going to be graded so that they do drain to the process pond. We want to keep that as a closed system to reuse that water. Dry plant area, raw sand and dry stockpiles will drain to a stormwater pond. As far as the design for the plant area, we're going to go above and beyond the Wisconsin DNR requirements. We have submitted the stormwater permit to the Wisconsin DNR. They're currently reviewing that for the plant area, the processing area. The two process ponds, I just want to check my notes here, make sure I got this. They are designed so that to retain the 100-year event in the process pond for those areas draining to it. So a 1% chance storm, very large event. Process ponds are sized to handle both the process water that's running the washing system as well as large event will go into storm process ponds. The other areas, we're going to have a series of storm ponds. Those also are designed to handle up to the 100-year event. Those will release water, but at lower than the pre-mining rate. So both the 2-year storm, 5-year storm, 10-year storm, 1-year storm, 100-year storm, we've looked at the runoff, stormwater runoff coming off the site now, and what will come off as the mining at the plant area is in operation. So again, we'll have a control structure that will release water, smaller pipe, store it in a wet detention pond, release it. Those ponds and also grass swale areas will also meet and exceed the Wisconsin DNR requirement for a reduction of total suspended solids. And again, the storm ponds are sized to handle up to exceed a 100-year event. We've also oversized that so that if that controlled release were shut off, we can still hold that 100-year event in those storm ponds. Throughout the project, right prior to starting, the first thing is going to be erosion control. We'll have erosion control again throughout the life of the mine. As we proceed through the mining, erosion control devices will be installed to minimize any sediment loss and keep it on site. Erosion control will include silt vents, erosion bales, sediment logs, slopes steeper than 4-to-1 slope will have erosion mat installed. Riprap will have ditch checks, riprap channels. So we'll have erosion control throughout the life of the mine. Within the mine, we're going to keep that internally drained. DNR wants to be internally drained. We want to hold at least a 10-year event. Again, the way we're going to be doing that is the outer boundary is going to be a minimum of 2 feet above the mine floor. And then within the footprint of the active mine floor, we'll have a 5-foot deep storm water pond, and it is also being sized so that a 100-year event is contained within the pond, and then we also have an extra 2 feet of freeboard that anything above that is going to flood the mine floor and not escape. So total mine area, as we proceed through that, we will be installing storm ponds within the mine phase. Mine floor will be 2 feet below the adjacent land, so it will stay within the mine floor. And again, rather than just a 10-year storm event, we're size it so that we hold greater than a 100-year event. Then the plant area, again, it's got the stormwater ponds. Process ponds will contain process water as well as stormwater contributory to that. And those ponds are also sized to hold at least a 100-year event. As well as with that release, we'll meet the DNR TSS, total suspended solids requirement. So as we proceed through here, every year we will be having an annual report that will go to the Jackson County for their review. There will be financial assurance provided so that in the case something happened and the county was stuck with having to reclaim this, the financial assurance will provide that. The financial assurance is going to be based on the open areas, and that the annual report will look at what areas are open, what has been reclaimed, and the financial assurance will be adjusted accordingly to ensure that it's adequate. But now turn it over to John Cross.
My name is John Cross. I'm the owner of Turnkey Processing Solutions at American Bennett Conveyor, and we design, we build, and we operate all types of mineral processing facilities, including frac sand operations like this. And so I want to answer any questions that that are related to the reclamation permit. I want to respect the process here, but I'm going to leave some business cards, so if anybody has any questions that don't fit into the plan, you can call me directly. My cell number's on here also. Or you can email me questions also. So we got a couple. I just got a couple of pictures I want to show you just to give you an idea of what this thing would look like from a installation standpoint. So Phil had mentioned that the mining phases, basically going to start mining here, and then then this starts to open up over the years, and then we begin to reclaim in behind it, and then this is where the processing facility is. When I'm designing a plant, what I'm trying to do is I'm trying to use the least amount of energy as possible to produce a quality product. So that so in the design, here, what we came up with was a portable primary crusher and a screen. And what we do is that we, as the face gets farther and farther away as you're mining, we take that portable primary and we basically chase that face. That way we can reduce the overall number of pieces of mobile equipment that we need to operate. Less trucks, less excavators, that type of thing. So this is a portable unit. Now that unit pumps the material over to the wash plant here, and the wash plant does a couple of different things. So the material that's coming out of the mine, right away we're adding water to it, and we're typically running, on any of the screens, running from about 12 to 15% moisture, and then as we go through the slurry pumps, it's like 85% moisture, and then when it goes into the wash plant, we separate it into different sizes. So when we go through and we separate those products into different sizes, we do that over a reclaim system. Again, we've designed this system so that we reduce the overall amount of mobile equipment again. And then that material comes out of here and is conveyed into the dry plant. And once that goes into that dry plant, everything is completely enclosed and has its own dust collection system. And forward this one. No way. Yeah, go up. So this is like a 3D rendering of kind of what it would look like here. Basically, what you have is you have that material that's being conveyed into the plant from the wash plant is being conveyed into this dryer. As soon as it goes into that dryer, we use natural gas to evaporate the moisture, and then that material goes into a screen. So that dryer itself has its own dust collection system, and then the material, we have a whole other system for all of the equipment after that dryer. So as soon as everything's dry, everything's enclosed, and everything's it's like being hooked to a big vacuum cleaner. And then in addition to that, we fill the building over all that equipment and then close it. So push it in there a little bit. So this is just another angle of that same thing, just to give you an idea of what that might look like. That's kind of an angle from the top there. And this is what the wash plant looks like. So we separate this sand into different sizes, and like I said, it goes over a canning system, and then this is the wash plant equipment. So all this material here, the lowest, and all this equipment that's being run in this wash plant itself, the lowest moisture level in that is around 12%. Everything is either 12%, between 12 and 85. And then it goes on, like I said, to the rest of the process to the dry. That's just an aerial view of the same thing. Elevation view. A little closer up. This kind of shows a couple of things. This is a thickener tank, so the water that comes out of the fine material that comes out of the plant goes into a thickener tank. This is a fresh water tank, and the thickener tank helps us to settle the solids out of these fine particles that we've washed off of the sand. And then that material gets pumped into a belt press, which further squeezes even more moisture out. We take that material, any other unsellable material that we get out of the mine, we blend those back together, and then we use that as part of the reclamation process. So that would go in first before the overburden, and then eventually the topsoil. So that's all part of that. That's all part of that whole process. That's just a close-up of the belt press building. All that goes inside, and it's enclosed. And that's a close-up of the washroom. So there's just a couple pictures just to give you an idea, so you can get some perspective of what it looks like. This is kind of project that was in process. It's like half built. So we got some screens in here. We're building a building over the top of it. This is just another example of some storage, all enclosed with a building that they're dumping into. This is kind of what it looks like from the inside. That dryer that I talked about that dries the sand. That's what this is here. It's got its own bag house, and then we just go ahead and put the whole thing inside of a building in addition to all those regular controls. This is another picture of the inside of one of those buildings. And then these are just the cut and fills that are. Those are his drawings. So that's kind of that's kind of what what it's going to look like. So I want to give you an opportunity if people have questions at what point you want to do that. But I'm available here to answer any questions that you may have related to the rec plan.
Okay, at this time, is there anybody here that has any questions of SEH or for John? Sheila?
I just wonder what his talk has to do with the reclamation plan.
He was able to describe some of the process.
That has nothing to do with the reclamation plan.
I was just basically trying to share so that you understood how we got to the point where we created that part of the product that we take into the which is the fine material.
One of the things you had mentioned, you said that during this whole course, you kind of streamlined all the energy that you're putting in so you can kind of pull back.
We do the best we can to try to use the least amount of energy as possible.
Okay, so you actually have an estimation of what actually is going to, what energy you're actually going to be used, or you have a guideline that basically says, here's where I'm starting, here's where I figure I'm going to be, and then later on you'll have to measure it to make sure that that actually is being followed, and how do you report that?
Yeah, basically there's a couple of different things going on there. One is you have mobile equipment, so you got some energy in mobile equipment, which is the part that's removing the overburden and removing the topsoil that Phil mentioned, and taking the sand to the plant. And then, so that's one part of it, and then taking the material back into the reclaim. So you got that piece of it, and then the other part of it is what it actually takes the energy that it takes to clean the sand and get it into a usable form and get all that fine material out that goes back into the reclaim. So there's kind of two pieces to that. So I've been doing this for over 30 years, designing, building, and operating these facilities. So, part of that's experience. One of my companies that actually manufactures this equipment is American Bin and Conveyor. They're located in Wisconsin, and we've been servicing the sand industry since World War II. So, I've got many employees up here, and so we're very, that experience helps us to make those decisions, on how to reduce that energy. If you ever actually get to a optimum, utopia, I don't know if that's possible, but we certainly do our best to reduce the energy.
Dwight?
You mentioned you're using natural gas as a drying fuel. Do you have access to that at that
That's
site?
the idea. In the event that we can't, then we would generally use propane if we can't get natural gas.
Okay.
So the dryer can use either.
What are the noise levels coming off of that plant?
Basically, it's about the same as the conversation we're having right now. Those are kind of typical levels. There's several things that, as an operator, that we do to reduce noise. Some of that is like what we did here, where we're putting a lot of things inside of buildings. The other thing, on the mobile equipment side, during nighttime hours, we're able to use strobes on the equipment. So there's a lot of things that we're able to do. Generally, what we'll do as an operator is we'll go around the perimeter of the property and measure the noise levels. And we really don't want the noise levels at the edge of the property to be really any louder than us talking to each other right now.
Air quality, is that monitored?
Air quality, we're going to have a public hearing for air quality, for our air permit, and there'll be some other professionals in there that have, that have more to add than I do. But I can tell you this: the the system that we design is state-of-the-art. It's automated and it's the best available control technology. We're using the absolute best bags that are available. So we're not skimping here. You know, like I asked these guys when we started out to make the ponds bigger, which he mentioned in his presentation, and Jack made that commitment to do that. Because as an operator, I realized those challenges of those, you know, those storm events and how we're going to keep that, you know, how we're going to keep that water on the property. So I wanted to make sure we had that. Well, we do the same thing with the air. You know, is doing this for 30 years, being responsible for protecting our employees. We've designed systems right here in Wisconsin that our American Bin and Conveyor Company, where we have totally enclosed conveyors with you know, just really awesome dust collection systems on it. And so, you know, that's part of what we're trying to do, is we realize these operations have an impact, and you know, we're doing everything we can to reduce those.
The monitoring is done by your company, it's not a third party?
You know what, I don't do it other than what's required by the state, as far as the monitoring goes. And everyone's a little bit different. You know, we build plants all over, we've done a lot of work up here. So as far as monitoring goes, you know, everything that we're required to monitor, you know, doing stack tests, opacity readings on a regular basis, all that stuff, we do all that. And if there's anything done in addition to that, it's outside of my purview. But we'll be dealing with those specific issues in the air.
The Wisconsin Department of Natural Resources are the ones that have the air quality control. So they normally have a public hearing, or an option for a public hearing. And that's through the DNR that does that.
And that's a separate permitting process?
That is a separate.
All the air permitting is
Okay.
done. All the air permitting is done as a separate process. And they'll do the same thing, public notice and set up some hearings. Like I said, at that meeting, we'll have some.
Can
some
adjoining
additional professionals.
landowners access that information, so we have some
Oh,
real-time?
It's all public. It's all
Yeah,
public.
okay.
Gentlemen,
Yes, a couple questions. First, will there be blasting involved in the mining process?
Yeah, some of the areas don't require blasting, but some of them do. So we will be drilling and blasting as a normal course of.
And then how many tons per hour is the output of the plant, the dry plant?
The final output is in the range of 200 tons.
200 tons. Thank you.
Great.
How many gallons of water do you use per day or per year?
I don't know per year. I'm not even sure per day. What we look at it on a per minute basis, and our makeup system generally runs about 200 to 250 gallons a minute. So that what Phil mentioned, that high cap well. So we're gonna, you know, we got a permit in to drill 400 or 500 feet deep, something in that neighborhood.
This area about
300 feet deep, and then we'll access a low aquifer, and then we'll pump our makeup water. Most of the water is just going around in a circle, and it comes out of the thickener, and the belt press goes back in the process, and we just keep doing that over and over. But we do need some makeup water, and that makeup water comes from that high cap well. Generally 200, 250, somewhere in that neighborhood.
I've heard reports where mines or processing facilities use up to 1 million gallons of water per day. Is that possible?
You know, there's all kinds of processing facilities, so and depending on how you design design the system, whether it's closed or not closed, or how you do it, so that I assume there's potential for that to be, but that's not the case here.
Brett.
You've been doing this for 30 years?
A little over.
Okay, and you've designed this facility already to a certain degree?
To a certain degree.
How far?
I would say that there's nothing in this facility that